Defining refraction and its effect. Refraction is the bending of light as it passes from one medium to another, caused by a change in its speed. When light moves from air, a less dense medium, into water, a denser medium, it slows down and bends, causing objects to appear displaced or bent. The role of light speed in refraction. Light travels at different speeds in different materials. In water, light moves slower than in air due to the water's higher density. This change in speed causes the light waves to bend at the interface between air and water, altering how we perceive the object beneath the surface. How refraction alters appearance. When light enters water at an angle, the light rays bend towards the normal, an imaginary line perpendicular to the surface. This bending causes objects underwater to appear closer to the surface and at an altered position, making them seem bent or distorted. Snell's law and refraction explained. The amount of bending in refraction is governed by Snell's law, which relates the angle of incidence, the angle at which light hits the surface, to the angle of refraction, the angle at which light bends within the new medium. The law helps predict how much bending will occur based on the refractive indices of the media involved. Why objects appear larger or smaller. Refraction also affects the size of objects as they are viewed through water. Because light slows down and bends when entering water, objects under the surface appear larger or magnified, especially when viewed from above at an angle. Seeing objects at a different depth. Refraction can make objects appear to be at a different depth than they really are. For example, if you look at a stick partially submerged in water, the part of the stick in the water seems to be at a different angle, often looking bent or broken where it enters the water. Refraction's everyday impact. Refraction is not only responsible for making objects look bent in water but also explains phenomena like the rainbow colors seen in a prism, the shimmering effects on the road on a hot day, and the apparent shrinkage of objects viewed through a glass of water. Applications of refraction in technology. Refraction is harnessed in various technologies such as eyeglasses, microscopes, and cameras. Lenses use refraction to focus light, helping us magnify objects or correct vision, demonstrating how understanding refraction is essential in both scientific and everyday contexts. The underlying mystery of refraction. Despite being a well-understood physical phenomenon, refraction still presents a visual puzzle. Our brains must interpret the bent light in a way that often leads to misjudgments about the location and shape of objects underwater, showcasing the complexity of light's interaction with different materials.